This is our last unit, Unit 4, and this unit is covering statistics. So what we're going to do is we're going to talk about how to gather and organize data, visualize it, and then we'll be talking about the mean, median, mode, range, standard deviation, percentiles, and the normal distribution. All right, so I'm going to go ahead and get started here. We're going to look at section 8.1, gathering and organizing data. So basically, you might be asking yourself, why do we study statistics and why do almost every single major require you to take a statistics class? The reason why is it's very important. It allows us to gather data and allows us to make predictions sometimes, and sometimes it just allows us to make, some changes, about things. So the first kind of statistics we're going to look at is descriptive statistics. So descriptive statistics is the act of collecting, organizing, summarizing, and presenting data. Inferential statistics is making generalizations, predictions, and conclusions about a universal set, which is the population, based on data collected from a subset, which is a sample of the population. Inferential stats would be, there's some political poll and it'll say that so-and-so is receiving political favor, maybe at 47%. Well, that's a sample of the population. So they're making a prediction based off of, not the whole entire population, but part of the population that completed the survey. Speaking about population of a study is a group that collected data and that is intended to describe. So the population is the whole thing, okay, the whole group. A sample is a smaller subset or a smaller portion of the entire population. Ideally, it's fairly representative of the whole population. And finally, random sample, or I shouldn't say finally because we have more left, but random sample is one which each member of the population has an equal probability of being chosen. By the way, random sampling is the best type of sampling to do if you can do it, because everybody has an equal chance of being represented. Sources of biases: voluntary response bias, self-interest study, response bias, perceived lack of anonymity, and loaded questions. So biases are when the data that they're gathering is kind of set up to be in the favor of the person gathering the data. For instance, if you go to Busch Gardens and they ask you, hey, did you have a fun time here? Well, that's not a good representation of the general public. It's just a representative of the people that go to Busch Gardens. So there's a bias built in there. Categorical data are pieces of information that allow us to clarify the objects under investigation into various categories. So maybe we're interested in doing a study for the hospital and we want to know how many people have lung problems from smoking. So maybe we're going to organize them qualitatively, like by age, for instance. Quantitative data are responses that are numerical in nature and with which we can perform meaningful arithmetic calculations. So quantitative data, for instance, would be your test scores. So if I wanted to find your average or your mean of your test scores, I would add up all the test scores and divide by the total number of test scores. That would be quantitative data instead of qualitative. Okay, so it says determine whether the following method produces a random sample. If it is not ideal, suggest a better method. So the first one says, I want to find out how much money did HCC students spend on textbooks last semester. So I will ask every student who goes into the Plant City bookstore, is this a random sample? And the answer is no, it is not. If you just want to know about the Plant City campus, then you would need to figure out everybody that spent money. Some people do not buy their books at the bookstore. Some people buy them online. Some people maybe purchase it through an outside bookstores. So, anyways, this would not be a random sample. A better method would be to find out every single student who went to Plant City HCC and maybe email them and ask them how much they spent on books. All right, I want to find out what American believes should be the legal age to drink alcohol. The poll was conducted on a news website, CNN, Fox, MSNBC, or PBS. So if you conduct the poll on a news website, again, it's not random. There's biases with people who watch particular news sources like CNN or Fox, for instance. So, no, this is not random, and it is not ideal. A better method maybe would be to send everybody in the state of Florida a questionnaire and see who responds to it. I guess that would be a little bit better. All right, frequency distribution. So now we're getting into the nitty-gritty of things in this section. A frequency distribution table is used to organize raw data by listing each data value with its frequency. Okay, so the frequency distribution table shown below, which it's over here, shows the number of goals Samantha's hockey team scored during the postseason tournament. So if we look at this, Samantha's team scored 1 goal, and this happened twice. The frequency tells you how many times it happens. So if their team scored 2 goals, that happened 5 times. 3 goals, that happened 4 times. 4 goals, that happened twice. And 5 goals, that happened once. Excuse me. The data values are the number of goals. Okay? So that's what we call data values. So we can write that up here. Data values. Okay. And the data items, or the raw data, is the complete list of goals from all games. So the data items are listed how many times it happens as a frequency. When the raw data was originally collected, it was probably in a different order. For example, so if we look at this, HCC marketing team polled students and asked them how many classes previously taken at HCC. Here are the responses, the raw data. So 8, 11, 6, 6, 12, 0, 4, 12, 8, 6, 11, 11, 11, 12, 8, 11, 9, 8, 6, 6, 6, 4, 11, and 8. Construct a frequency distribution table. Okay, so we're going to use that terminology, the data values and data items. So the data items is your frequency. How often does it occur? And what I'm going to do actually on the side here is I'm going to do a tally. And tally means just to sum up. So I'm going to use tally marks to figure out what they are. So let's look through this and try to place these in order. So 0 is the smallest, so I'm going to put that first. And I only have 1 0, so I'm going to cross that out. And then I'm looking to see if I have 2, no, 3, no, but I have 4. So I have 1, 2 4s. Okay, so data value, the frequency is 1 for 0, 2 for 4. Okay, let's go to the next one. It looks like 6 is the next one up. So 1, 2, 3, 4, 5, 6. So I'm going to put a 6 there as a frequency for 6. All right, now let's look at the next one up, which would be 8. So 1, 2, 3, 4, 5. Next one up from 8 is 9. And I only see 1 of those. And the next one up from that would be 11. 1, 2, 3, 4, 5, 6. All right, and then 12. 1, 2, 3. Okay, so that's a frequency table. Again, your data items are your frequency, how often does it occur, and the data values are located in the left column. All right, usually frequency distribution tables are done with data collected by thousands of data points. All right, so I'm going to stop here, and I'm going to pick up with this one. So this is going to be part 2. All right, thanks for watching part 1.